Greetings, this is Mr. Garwood with our continuing video series on Calculus 2nd edition by Briggs, Cochran, and Gillette. This video is going to start our discussion on section 3.7, which is the chain rule. Now, I'm going to start with a simplified version of this problem, and then I'm going to show you how this problem gets more and more useful the higher order we go. So our first example here is I'm going to look at the function f of x equals the quantity 5x plus 4 cubed. And this is actually the setup problem that your book uses looking at the start of the chapter on page 161. What I want to notice here is that I can rewrite this, and I'm going to rewrite this intentionally with some different colors so you see what's going on. That realistically, this section that I'm now writing in blue, this 5x plus 4, actually is another function. So if I define g of x to be 5x plus 4, what I'm really saying is that f of g of x is g of x cubed. Now, Mr. Garwood, why does this matter? Well, the big issue here is that for me to find this derivative by the methods that we developed earlier in this chapter, I believe in sections 3.3, is that I have to expand this. And so I'm actually going to do that to show you how difficult this is for a cube. So I'm going to say 5x plus 4 times 5x plus 4 times 5x plus 4. So I'm going to FOIL these first two terms. So I've got 25x squared plus 20x plus 20x plus 16, and all of that still multiplied by 5x plus 4. Well, now I get to multiply everything here by everything there, so I've got 125x cubed, so that's 25x squared plus times 5x, plus 100x squared, so that's 25x squared times 4, plus 20 times 5 is 100x squared, plus 80x, that's 20x times 4. No. Ooh, I forgot to add those together. Well, it's all right. We'll just keep rolling. So 25, that one. So that's the first two. Then we're going to get this one again, just because I forgot to combine the 20x, the two 20x's into 40x. Plus 80x, plus, and then 16 times 5 is yet another 80x. And then 16 times 4 is 64. So combining like terms, I've got that f of x equals 125x cubed plus 100 plus 100 plus 100, so that's plus 300x squared plus 240x plus 64. Okay? Now, using our rules from before, the derivative of f with respect to x is 3 times 125 is 375x squared, plus 2 times 300 is 600, x plus 240. Now, kind of gross. Here's the magic of the chain rule. The chain rule in your book, I don't know why I just moved all that. So the chain rule in your book says that for f of x, which has a function, so this is just using function composition. For f of x where I can say that f is some function of u, or that u is some function of x inside of f, then what I can do is say that the derivative of f with respect to x is the derivative of f with respect to u times the derivative of u with respect to x. What does that mean, Mr. Garwood? Oh my goodness. So for f of x equals (5x plus 4 cubed). Okay, what I'm going to do is I'm going to come over here and say u is 5x plus 4. And then what I'm going to do is I'm going to rewrite f as f of u equals, and I'm going to replace whatever u is, so 5x plus 4, with u. So I'm going to say f of u is u cubed. Okay? Now, next thing I'm going to do is I'm going to evaluate du dx. So du dx, I'm going to take the derivative of 5x plus 4, which is 5. And I'm going to differentiate f. Df dx equals 3u squared. And that's using the power rule. So both of those use the power rule. Now check this out. This is where this gets fantastic. Okay? So df dx is df du times, oh, let's start this over and let me do it in fun colors. Df dx is du. Df du times du dx. Okay, well, df du is 3u squared. Du dx is 5. Now what I'm going to do is I'm now going to go back in and I'm going to resubstitute u in for f. So this is 3. Let's do it like this. This is 3 times 5x plus 4 squared times 5. Okay? So 5 times 3 is 15 times 5x plus 4 squared. And what I can do now, if I want to confirm that this is the same actual answer as I got before, is I can actually now FOIL this. Now if I go back to my previous work, I know that 5x plus 4 squared, that's 15 times 25x squared plus 40x plus 16. Now, 15 times 25, that's 10 times 25, so that's 250 plus 5 times 25, which is 125, so 250 plus 125, 375x squared. 15 times 40, 600. 16 times 15, 240. Wait, look. I didn't have to do all that horrible expansion, and look, exactly the same answer. Fantastic. That makes me super happy. And here's where this gets better. Real quick example before I wrap up this video. F of x equals 5x plus 4 to the 100 power. I do not want to expand that. You could not pay me to expand that. But, just like I did before, u equals 5x plus 4, which means that du dx, again, is 5. F of u is u to the 100, which means that df du is 100u to the 99 power. And I just go back in and I plug in stuff, so I've got df dx is df du times du dx. Well, df du is 100 u to the 99. Du dx is 5. And now all I have to do is put stuff together. So that's 5 times 100 is 500 times u 5x plus 4 to the 99. And I still have no desire to FOIL that or to expand that out, so I'm going to leave it right there. One last thing I want to leave you with before I go away. When I say df dx equals df du times du dx. If I think about this as traditional rational function multiplication, which is not the worst way for me to think about this, here's what I want you to notice. I've got du on the top, I have du on the bottom, which means that I can consider those a pair that multiply to 1. And what am I left with? I've got df over 1 equals 1 over dx, and if I multiply those, I've got df over dx. I hope you found this video useful. Good luck as our semester continues.